In this problem, we were asked to find the quadrupole and octupole terms for the physical dipole here, carrying out the binomial expansion, kind of how it was initially introduced in Griffiths. And so, just as a reminder, the script r plus and script r minus are the vectors that go from the positive source and the negative source to our point of interest, which is out here, which is a distance r away. And so we can use the law of cosines to write down what the magnitude of script r plus, using a law of cosines, r squared plus d over 4, d squared over 4, minus r d cosine theta, and script r minus squared is r squared plus d squared over 4, and then plus rd cosine theta, where theta is the angle between d and the r vector to our point of interest. So at this point we just need to start writing down the binomial expansion, and so we'll go ahead and do that. I'll try and do these together. 1 over script r plus or minus is going to be equal to just taking this expression. I'm going to write r squared plus d squared over 4, then minus or plus, where the minus here goes with the plus, the plus here goes with the minus, rd cosine theta, and this is to the negative 1/2 power. And so the negative 1/2 power, the negative flips it over, the 1/2 takes the square root, so that I get 1 over the magnitude of that. The next term is just to factor out. We're going to say that this distance r is much, much greater than d. So that's our assumption. And we're going to use that by essentially factoring out an r squared. And so this will give us 1. I'm going to slightly rearrange the terms here. R over d cosine theta plus 1/4 d over r. There we go. D squared over r squared. To the minus 1/2 power. Now when I distribute the minus 1/2, the first term is easy. And so this is going to be 1 over little r. The second term I'm going to factor out. This is 1 plus x, where in this case I'm going to identify x is equal to minus or plus d over r cosine theta plus 1/4 d over r quantity squared. And now the trick, oops, sorry, this is to the minus 1/2. And now the trick is we use the binomial expansion, because we're going to say x is very, very small in comparison to 1. And so we're going to use the binomial expansion of this term, this 1 plus x to the 1/2 power. So let's go about doing that. That's not too hard at all. And so this is a reminder, 1 plus x to the 1/2 power is going to be equal to 1 plus, then, sorry, that's minus 1/2 power, minus 1/2 over 1 factorial times x plus minus 1/2 times a minus 3/2, so I subtract 1 over 2 factorial x squared plus minus 1/2 minus 3/2, subtract 1 again, minus 5/2 over 3 factorial times x cubed plus dot dot dot. And so that is the binomial expansion there. It's going to simplify down for us. Whenever I plug in my expression here, I'm going to get that this is equal to 1 plus, yep, why did I write plus, minus 1/2 times our expression here. So minus plus d over r cosine theta plus 1/4 d over r quantity squared. The next term is 3/8 plus 3/8 minus or plus r cosine theta plus 1/4 d over r quantity squared, whole thing squared. The next term is minus 5/16 minus plus d over r cosine theta plus 1/4 d over r quantity squared, whole thing cubed. If we carry it out to the fourth power, which is what we want to do in order to make sure that we get out to the octuple term, we're going to do plus, next term is 35 over 128 if you carry out all the little nigglish math. And so that is kind of that horrible thing as it stands. And so you say, what the heck do I do with that? And the answer is a lot of algebra. But unfortunately, I'm not going to do the algebra in front of you because I have access to Mathematica. So I take this and I use Mathematica to gather powers of d over r for me so that I don't have to do it on my own. And so, when you do that, I'm going to remind you that this is 1 over script r plus or minus. Gathering powers from Mathematica, powers of d over r, gives us 1 over r, 1 minus or plus 1/2 d over r cosine theta. So that's the first term. The second term is plus 1/8 d over r squared times 3 cos theta, cos squared theta minus 1. Next term gives us minus or plus 1/16 d over r cubed, 5 cos squared, cos cubed theta minus 3 cosine theta. Next term gives us plus 1 over 128 d over r to the fourth, and 35 cosine to the fourth theta minus 15 cosine squared theta plus 3 plus dot dot dot. So there's a lot of algebra that went in there. Again, simplify it by using Mathematica, but now we have back to what we want. If I want to find out what the potential for the system that I looked at up here, which is for this physical dipole, I can write that out, that V of R is going to be equal to Q over 4 pi epsilon naught, and then 1 over script R plus minus 1 over script R minus. And now we see a beautiful symmetry. Oops, there you go. And now we see a beautiful symmetry for the problem that we can take advantage of. I'm subtracting these two, but the signs of all of these terms will switch, while the signs of these terms won't switch. So the ones that don't switch will cancel out whenever I subtract the two. So I'm not going to have that term, I'm not going to have that term, and I'm not going to have that term. And so we are left over then with just adding that term and that term together. So we are left over with potential is equal to Q over 4 pi epsilon naught d over r times cosine theta plus 1/8 d over r quantity cubed times 5 cosine cubed theta minus 3 cosine theta. And so this is our dipole. This is the octuple. And the quadrupole term canceled out just like the monopole term cancels out. The dipole term is here, the octuple term is there, and other terms cancel out.